Welcome back, ladies and gentlemen. Today we're going to look at something a little different than exponents in this unit. We're going to start looking at scientific notation, but scientific notation uses exponents, so that's why these two topics are in our same unit. So let's look at scientific notation. Scientific notation is used to represent very small or very large numbers so that you can condense them and write them easier and use them easier instead of having a big long string of digits that you are writing out. So with scientific notation, we're going to be using powers of 10, and that has to do with our place value. Ones column, tens column, hundreds column goes by a power of 10 with each place that you go. For scientific notation, it's going to be written with a decimal multiplied by the power of 10, and then this exponent is going to represent the number of decimal places we've moved the decimal in that number. Now, I said the first number is going to be a decimal, and you can see, if you find the decimal point, that there's a whole number to the left of the decimal. That number or factor to the left of the decimal must be between 1 and 10, but it cannot be 10. It has to be less than 10. So it can be the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9. That is it. So you're just going to have a single digit to the left of the decimal. You cannot have a 2-digit, 3-digit, 4-digit number to the left of the decimal and have it correctly written in scientific notation. It's just going to be one number to the left of the decimal. It doesn't matter to the right how many you have. It's just to the left, you must only have one number that is equal to 1 and less than 10. So let's look at this as written. It wants to know if it is written in scientific notation. So what you're going to look at is there only one number written to the left of the decimal point? So if we look at the first example, we have 5.9 times 10 to the negative 6. There's my decimal point. I look left, and I see the number 5. And the number 5 is between 1 and 9, and we're going to include 9 in that. So that would definitely be written correctly in scientific notation. But if we look here, we look left of the decimal, there's a 0. We can't have a 0 there. It has to be a number equal to and less than 10, or equal to 1 and less than 10. Well, 0 is not equal to 1 or less than 10. It's less than 1. So this number right here could not be written correctly in scientific notation. Now, when we have a number written in scientific notation, we can actually take that and convert it and write it in standard form. The value of the exponent tells you how many places you're going to move the decimal. So if it was 10 to the power of 3, you would be moving that decimal 3 places. Now, if the exponent is negative, you're going to be moving the decimal point to the left. If the exponent is positive, you're going to be moving the decimal point to the right. And again, when you're working on your homework and you may get stuck, reference this part of the video so that you can go back and get a quick refresher of the rules in solving these scientific notation or writing scientific notation problems. So there's our rules. Negative exponents, move the decimal left. Positive exponents, move the decimal to the right. So let's write some exponents in standard form. Our first example, 3.22 times 10 to the negative 4th power. We have the negative 4th power, so we have a negative exponent. Which way do we move our negative exponent? To the right or to the left? We move it to the left. So we're going to be moving our decimal point, and here's how I do this. Our decimal point, 1, 2, 3, 4 places to the left. And you can see we've done that here. We've taken the decimal point, which was originally right here, and moved it 1, 2, 3, 4 places. Now, what do we do in front of this? Well, we can add zeros in to all these little loops that I made. So the 3 goes here, but then there's a 0, 0, 0, and my new decimal point is right there. So in standard form, we have a really small decimal, 0.000322. So that is correctly moved 4 places to the left. Let's take a look at this one, 7.9 times 10 to the 5th. We have a positive exponent. Positive exponents we move to the right. So we're going to move the decimal point to the right 5 times. Again, how I do this, I'm going to take 7.9. Whoops. And I'm going to move my decimal 1, 2, 3, 4, 5 times. There's my new decimal point. And I'm going to fill in all these little half loops with zeros. So my decimal point's now at the end of this. So my number is written as 790,000. So I move the decimal point from here to here. 1, 2, 3, 4, 5 spaces. So you're moving the decimal point. Let's take a look at a few more examples in which we are writing numbers in standard form. First question asks, is it written correctly in scientific notation? Is it written correctly in scientific notation? No. Why? Because right here would technically be the decimal point. And we can't have a number bigger than 10 written to the left of our decimal point. So our decimal point should have been there, 1.2. And then since you would have moved it to the left, one more, that should actually be a 3. So no, this is not written correctly in scientific notation. It should be moved 1 decimal place, and we would have to change the value there too. Now let's practice again, writing in standard form from scientific notation. 6 times 10 to the 7th. So I have the number 6. My decimal point's right here. 7 is a positive exponent. Positive exponents, we move the decimal point to the right. So I move it from here to 1. I move it from here. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So my decimal point's here. So now I write the number out. Well, I'm going to count to make sure I have my commas in the correct places. Every 3 place values, there's going to be a comma. It's not cooperating today. There's going to be a comma here and a comma here. So our number would be written as 60 million. You can see my original decimal point was here, and I moved it 1, 2, 3, 4, 5, 6, 7 places to be there. Next one, 9.9 times 10 to the 5th. I'm going to go ahead and put down my value. 10 to the negative 5th. Our exponent is negative, so I'm going to be moving my decimal point to the left. Negatives, we move to the left. So I'm going to draw my loops here again, starting at my decimal point. 1, 2, 3, 4, 5. 5 places to the left. So I'm going to fill in with zeros and put my new decimal point. Now since my decimal point's there, I rewrite my whole number. 0.0000.000099. So that is our standard form of this scientific notation. One more. This one, 1.285 times 10 to the 4th. So I'm going to get rid of that 10 to the 4th here as we work through it. 10 to the 4th, we have a positive exponent. Since it's positive, we move the decimal place to the right. Our decimal is right here. So I'm moving it 1, 2, 3, 4 places to the right. So there's 1 place, there's 2 place, 3 place, 4 place. Now the 285 took up 3 of those places. And I have an empty place here. What do I fill in? A 0. Where's my decimal point now? At the end. So let's rewrite our number. And every 3 we need a comma. So 12,850 is how we would correctly write that in standard form. So go ahead and work on your homework. That's attached in Google Classroom. If you have any questions, I would first suggest going back and watching the parts of the video that would help with that question. And if that still doesn't help, please reach out to me for assistance. Go ahead and work on your homework, and I'll see you next time.